So if we're going to be adding rational expressions, it's going to be just like adding a regular fraction like we have here. So the first thing we have to have is you have to have that common denominator, right? It's going to be the focus of today's classes. We need a common denominator. That'll be the challenge, right? Making sure we find it. Now, with a problem like this, we are given a common denominator. So, how do we add fractions? Just a reminder. The same thing when we do these crazy polynomials. Adding fractions is adding fractions. You know, add the numerators. That's it. So then we're going to add, right, or subtract, because that works as a minus, subtract. And then at the end, we always try to simplify, right? So we'll just add numerators, add or subtract numerators. And then simplify if possible. But most of the time we can't, but simplify if possible. Sometimes we can. So then this becomes 3 goes into 6 twice, and we're done. These are just regular easy fractions to deal with. So let's change the problem, and let's look at some, or a rational equation. We have this x over 2x plus 3x over 2x. So let's not worry about right now the fact that these can be simplified. That's not the point here, right? The point is just to look at a fairly straightforward rational expression where we already have the same denominator. So if you have the same denominator, simply add it, subtract numerators, and then simplify at the end if we can. So what's x plus 3x, everybody? We get 4x on top. The bottom does not change, right? Because once you have a common denominator, you just leave it the same. And so then simplify here, right? Now, if our answer, so we go with 2x goes into 4x twice. Now, maybe our answer was something like this, and it wasn't, but maybe our answer was 2x plus 4, and our denominator was x plus 2. And this was our final answer. Once we added everything together, this is what we got. What can you do in the top? Right? You can factor out a 2, right? So to simplify if possible, just if that means is we should be thinking simplifying rational expressions means you might need to factor. So then in this case, we have to factor out a 2, and then we can cross off the expression. So that process doesn't change from what you just took a quick on, right? That process is still the same, and this will come up. So first one, Noah, just add the numerators for us because we know the denominator stays the same. Yeah, we don't have like terms, so we actually can't add them together. The denominator doesn't change because it's already the same. We already have like denominators. Okay, so then that means at this point we need to try to simplify, Bella. All right, and then now this is just a simplified problem. We've now done a ton of these, so y plus 1 divides with itself. We're left with a 3y as answer. Okay, let's do the same thing. Now let's add numerators here. Haley, what do our numerators become in part B? Denominator doesn't change. All right, but this one looks like we can simplify a bunch of stuff. Hannah, how do we factor the numerator? All right, now sometimes we're going to be able to factor both and nothing will cancel out, will divide out. But in this case, something will. Bella, how do we factor the denominator? So these problems are very straightforward if you're given the common denominator, right? If you already have that, it's nice. Just add the tops and then simplify if possible. Most of the time, though, right, that makes for not very interesting problems if you always have the denominator. So that's the rest of our focus, is finding that common denominator, right? So put this online. So finding a common denominator, when you have, we've got two scenarios that I put up here. One of them is with monomial, meaning there's just one thing in each part here, right? In each fraction. So this is going to be look very similar to what you guys have done in the past. So if we're finding the least common denominator, right? LCD for least common denominator. For your numbers, start with your numbers. Numbers is just like a normal fraction. So what is the least common denominator of 3 and 6? Ignore the x for right now. No. Honey. 6. So for just dealing with the numbers, it's just 6, right? 3 goes into 6, 6 goes into 6. It's the smallest number they both go into. That's what we call a least common denominator. So if you think about that, we'd have to multiply this left fraction by 2 over 2 times 3 gives you 6. The variables, we simply need to make the denominators identical to each other, right? Make denominators identical. So we have one x on the left, meaning what's missing on the right? X. So you'd have to multiply the top and the bottom by an x. If we actually did this multiplication, you'd get 4 over 6x plus x over 6x. We have common denominators? Yes. So now we can add these up, and they're not like terms, so you simply get 4 plus x over 6x, and they don't have anything in common, so we're done. There's nothing to cross off. So if you're given monomials, just treat it like a normal problem and deal with the variables at the very end. But you just have to find the lowest number they both go into. So with 3 and 6, 6 is the smallest number. All right, now with something like this where we have binomials, we have to do a little bit more work. Right? So then let's actually put a kind of a definition here of how least common denominators are going to be when we're dealing with something that we can factor, right? Be a trinomial, binomial, whatever. It's going to look like this. We're going to take each different factor. The greatest number of times it appears. Take a second, jot that down, and then we're going to go into a lot of detail about what that means. Each different factor, the greatest number of times it appears in the denominator, or in a denominator. Each different factor. So how do you know if one is different from another? Well, let's just look at this. If we were to take these two denominators, if you put them over each other, x minus 3 over 3x plus 4, and it doesn't matter how you think about it, you can flip that fraction. Can we cancel anything? Is there anything that divides out of this fraction? Back as if this were a quiz question. Can you simplify this? No. So because you can't simplify it, it means they have nothing in common. So if I gave you a fraction like this, 1/3 plus 1/4, what do 3 and 4 have in common? Nothing. So when they have nothing in common, what do you do with them? You multiply them together. Exact same thing here. So what we're going to do, these two have nothing in common, and if we follow these rules, each different factor, if we're finding our least common denominator, we're simply going to list the factors. So there's x minus 3, and there's 3x plus 4. That's your least common denominator, and so if you wanted to make them the same, the left side is missing a 3x plus 4. And the right side's missing an x minus 3. This is the same thing as just multiplying the denominators together. It looks totally different. It's the same process. Yeah. There's nothing here that you can cross off. You can't factor anything else. This is not factorable. This is not factorable. They have nothing to simplify. So let's actually do a couple of these together on this and look at them. So we just need each different factor, the greatest number of times they So let's say we look at this problem, x over x minus 3 plus 2 over So this first one is probably the most straightforward of them all. Maybe not, maybe you disagree. James, what'd you get for part A, for your common denominator? This one is simply 4x. We need to multiply the left by 2 and the right by x over x. And then this is the smallest number that they both go into. All right, next 3 I want to take volunteer. So we're finding least common denominator. That's each different factor, the most number of times it appears in a denominator. So volunteer for part B. These two have nothing in common, so all we do is multiply them together. So if we were adding these, we're not right now, but if we were, we'd multiply the right side by x plus 1 over x plus 1, and on the left we do x plus 3. All right, let's keep moving on. Part C, different volunteer. Our least common denominator doesn't. That's it. Because once we do that, we have the same denominator. So our least common denominator is simply x plus 3 times x plus 4. You don't have to do anything to the left side. It's already taken care of. The right side, though, needs that x plus 3. All right, part D, the most involved of all of our problems. Lily, why don't you start us off and I'll call on someone else to finish the problem. What did you do first? All right, now somebody else. Given that we just factored, what can we do from here, right?
You see, we'll be crossed out, whatever.
Okay, so we see that x plus 3 is in both. Okay. What else? There you go. You have to have all the different factors. So x plus 3 is in both of them, but that still is a factor that has to show up. And then x plus 1 needs to be there and x minus 1. So when you actually do this, you would multiply this fraction by x plus 1 over x plus 1. And this fraction you need to multiply by x minus 1 over x minus 1. Whatever it's missing, so then these two denominators are identical. That makes the common denominator. So this first one, if you're unsure about something, just go back to, you can always look at this, like 2 over 2x minus 3. Is there anything that we could simplify here? I'm looking at this red part. No. So because we can't simplify anything, that means they have nothing in common. If they have nothing in common, multiply them together. So that means the common denominator has a 2, one factor, and the other factor is a 2x minus 3. Right? They have nothing in common. In part B, though, they do have something in common. So our least common denominator, if we're thinking about different factors, we know it's going to have a 3x. But this right side, somebody factor this right side for us, because it is factorable, right?
3 times.
Okay, so now look at both of these already have a 3. That is a common factor between them. So we're not going to have to multiply either fraction by 3, but we're going to need an x, and we also need this new factor of x plus 6. So this whole thing together is our common denominator, meaning the right side is missing an x, the left side is missing an x plus 6. All right, down here, part C, we need a factor first. So we factor the left denominator, Wilson. 2x cubed times x plus 5. Awesome. So now when we write our least common denominator, I would just work left to right. You list the different factors and then see if we have to add any more. So we have a 2x cubed. We have an x plus 5. And then we notice, oh look, there's another x plus 5. It's in a denominator, so they have this in common. They're missing the 2x cubed, so that means we'd have to multiply this side by 2x cubed to make them identical. And then one more, we need a factor again here. But else factor the bottom left for us. Well, x plus 4, x plus 6. Once again, just working left to right. List your different factors, so I see an x plus 4, an x plus 6, and then go to your next one. It's x plus 4 again, so that's it. We've covered everything for you guys. So with part A, what we need to do is multiply the top and the bottom of each fraction to make the denominators the same. So the right side is missing a 2, so we multiply that by a 2. The left side is missing a 2x minus 3, so we multiply by a 2x minus 3. And then I'm going to rewrite this problem down here, and by distributing, right, and there's nothing to distribute here, we get a 2x minus 3 plus 12x minus 10, and our denominator here is a 2 times 2x minus 3. You can actually just skip the step of writing two fractions, because now that they have the same denominator, write that as one fraction. Now we're going to combine like terms, so we will see, okay, 2x and 12x, those are the like terms in the numerator, so we're going to add those to get a 14x, negative 3 and negative 10 combine to a negative 13, and I would not multiply your denominator out, leave it. This is a perfectly acceptable answer. Right? So leave it just like this. Now, the top can't be simplified, can't be factored, so there's nothing to cross off. We're done. End of the problem. Right? Funny looking answer, but that's right. This is it. Now the next one. The right side is missing, so look at your common denominator. The right side is missing an x. So we have to multiply the top and the bottom by an x. And then it would become the common denominator. The left side is missing an x plus 6. So we multiply the left by an x plus 6. Multiply, so we get an x plus 6 minus 4x. And I'm going to write this as one fraction. 3x times x plus 6. And now we will combine like terms. It looks like we're going to get a negative 3x plus 6 over 3x x plus 6. Okay? And we always check to see if we can simplify. Is this a problem that we can simplify? Yeah. Actually is. If you factor out a 3 here, the top will become a 3 times negative x plus 2 over 3x x plus 6. So let's get rid of that 3 in front to get a final answer. Negative x plus 2 over x times x plus 6. Awesome. So far, so good on the board. I know that there's a lot going on, but we're just multiplying really by what we're missing. So then in this next problem, common denominator, 2x cubed times x plus 5. This is the entire common denominator. Awesome. So the left doesn't need anything. Really nice when you only have to multiply one side, which means the right side is missing a 2x cubed. And that's it. Now we have the common denominator, so when I rewrite this down below, you're left with a 5 minus 6x cubed over 2x cubed x plus 5. That can't be factored, which means we're actually done. This is it. So what appeared to be a fairly complicated problem actually was, in terms of number of steps, did not involve very much work. All right, and then finally, common denominator here of an x plus 4 times x plus 6. The left fraction already has a common denominator. That's awesome. Which means the right fraction simply needs an x plus 6 and an x plus 6. Then we'll rewrite this, x minus 2 Now, I guarantee this is going to be an easy thing that you guys are going to get frustrated with when you make the mistake is you're going to multiply by a 6 and add these and not multiply by a negative 6, right? So this should be a negative 6x minus 36 because we're subtracting all over x plus 4, x plus 6. Combine our like terms here. So I see an x and a negative 6x, so negative 5x, negative 2, negative 36, negative 38, over x plus 4, x plus 6. They have nothing in common,